So by now we have our game up and running. We've got a lot of complexity in there. We've used functions to refactor our code and to make it streamlined. And we've got a really robust and flexible program that can handle all different types of user input. So I've got a couple of challenges for you now. First of all, I want you to use a list to store the number of guesses taken for each game. So as your user goes through the game, maybe it'll take them 5 times to get it right the first time, 10 the second time, 1 the next, and so on. I want you to store those numbers in a list. So this will recap some of the concepts we've used earlier. Then once you've finished that, when they decide they don't want to play anymore, you can loop through that list to find out the best score from all of the games that they played and display that message for them on the screen. So pause the video now, go back to your code and see if you can implement these ideas into your game. So if we jump back into the code that we had up and running before, we need to think about how we're going to implement this list. And this list is going to store the number of guesses it took each time we go through, in this case, our function. So what I'm going to do is I'm going to make a new list that's in our main routine here, and I've called it scores. And remember, we've got these square brackets to create our empty list. Then we need to think about where we want to add information into that scores list. We only want to add a number to it once they've correctly guessed the target number that they're looking for. And if we look up here into our main function, we have this section, if the guess is equal to target, we print congratulations, you got it right. And I've just added one more line of code saying that we need to append to the scores list whatever's stored in the variable count. And that's the name of the variable that I was using to keep track of the number of scores that they had. So that's it for that first step. We've got our scores list set up, we're appending the different values to it, and then at the end we just need to loop through and find which is the smallest, in this case the minimum number in that list. So to start with this process, I've gone to the bottom of my code after we finish this repeat loop, so that the user has said no, I don't want to continue anymore. And now I've got this loop that I've created here, and this is the syntax that we had before, where we're looping through a list, because remember, scores is the name of the list that we created previously. Then I've said for score in scores, and remember this score, this is just a variable name that we've created. It makes sense to call it score in scores, but again, like the example we had a while ago, you could call it potato or whatever it is you wanted to. It would still work as long as you were consistent throughout your loop. So here we're going to loop through the scores list as many times as necessary, and every time we go through we're going to print out what their score was. I've added a little bit more complexity here by creating this turn variable. This is used so that we can have nice tidy output. As you can see here, it'll say your score for round and then whatever turn it is, so the first, second, third and so on, and then it will have the number, the appropriate number alongside that. Let's just quickly run it and see how that looks. So I can see we look for 99, so I'm just going to get them really quickly here. So that's going to be 1 guess. Let's play again, and I'll make it 2 guesses this time. And play one more time. And a few more guesses this time. So now you can see that we've got the output from that, and I need to say, no, I don't want to play again. And here's our nicely formatted output. So your score for round 1 was 1. Round 2 was 2, and for round 3 was 5. That's based on what's stored in this turn variable there. So the final step for this program is to work out what their best score is in all of the rounds they've played. We've already got this loop set up, so it's not going to be too difficult to add that code in. We are going to need another variable though, and we're going to have a variable that's going to store the current best score. So before we even get into that loop, I'm going to create that variable. And rather than storing 0 in it like I have done with turn, I'm going to put a large number in, so the number 100 in this case. The idea with this is that every time we go through the loop, we're going to compare the round score with the current best, which will start at 100, and we will replace that with the lower number as necessary. So if we started with a lower number, it just simply wouldn't work. We have to start with a number that's bigger than the number of guesses it will take them to get it. Okay, so thinking about the code we're going to need, we're going to use a conditional structure, so we've got our if statement, and we need to compare best, the value that's stored in best, and the value that's stored in score. So if the score from that particular round is less than what's in the current best variable, then we want to replace what's in best with the current score. So we say best is equal to score. So now every time we go through this loop, let's say the first time through the score is 5. 5 will be less than 100, so therefore best will be storing score, which will be 5. And every time we go through that loop, we will compare the new score to the current best and replace it as necessary. Before we run this program and test it, we just need to add one final line of code that's going to be outside our loop, just to say what the best score actually is. So my print statement is in place there. Let's run the code and make sure it's working as we'd like. So first time through, I'm going to take a few guesses to get it right. And this time I'm going to get it right first time and say no, I don't want to play again. And you can see it took 3 guesses the first time, 1 guess the second time, and overall our best score was 1, which is appropriate, so it's working properly. Have a go at implementing that into your code, make sure you've got that working, and we're just about finished for this guessing game.